Welcome to Vision 2222, the podcast where we explore the scientific, technical, social, and human changes that we might see if we were able to travel 2 centuries into the future. We interview leaders in science and technology and experts in business and the humanities to look into the possibilities of the future. Our guest today is Luc Boyer, who earned his PhD in materials science from Rice University, worked alongside Mikhail Gladkikh in advanced manufacturing at Baker Hughes, and is now with Carpenter Additive, a leading materials and manufacturing company. Vision 2222 is the brainchild of Mikhail Gladkikh and his 2 co-hosts, Amanda Chadee and myself, John Marsh. I'm an administrator in a materials science department at a major university in Houston, Texas, where I get a ringside seat to see people like Luc Boyer as they work to discover the new materials that will enable us to make it to the future.
I'm Amanda Chadee, consultant and mentor to early stage startups in biological and life sciences. I specialize in business development and funding strategies to support early stage startups in the big leap from lab discoveries to creating and selling a valuable product.
And I am Mikhail Gladkikh, your co-host. I am a technologist specializing in digital supply chain, additive manufacturing, and what is called Industry 4.0 in general. In my spare time, I write science fiction. And it is my pleasure to introduce our guest speaker today, Dr. Luc Boyer. We've known each other for a long time, since we both worked at Baker Hughes, pushing the boundaries of industrial 3D printing. Dr. Boyer is an expert in materials, processes, economics, and everything else that constitutes a broader knowledge of additive manufacturing, commonly known as 3D printing. Dr. Boyer has a PhD in materials science and engineering from Rice University and has established himself in the additive manufacturing industry as an expert in many areas. And now he's advancing this field at Carpenter Additive. Earlier this year, Dr. Boyer, Luc, invited me to participate in his podcast at Carpenter Additive called Powder Heads. And now it is my time to return the favor. Luc, welcome to Vision 2222. I'm really happy to have you with us today and looking forward to the intriguing conversation about the future of design and manufacturing.
Mikhail, always a pleasure to reconnect. John, it's been ages, and I'm very happy to have you on the line. And Amanda, it's really very nice to meet you for the first time. Thank you very much for having me for the podcast. So just to add a little bit of flavor to the introduction, currently with Carpenter Additive, I'm located in the Huntsville, Alabama area, leading additive manufacturing teams. We're serving customer and government R&D projects focused around the additive manufacturing space. In my current role, I manage both the R&D as well as operations team in the additive manufacturing, and also leading applications team to help customers bring customized powder handling and inventory management solutions for those who are scaling their additive manufacturing production and operations. So really moving from R&D through their additive journey into full-scale production. I've had the pleasure of starting several additive manufacturing efforts and facilities from the ground up with Baker Hughes, with Mikhail, and now with Carpenter Additive. And some of the discoveries that I've come along the way have really been about enjoying the challenge of bringing young engineers and guiding them through their journey and through their own professional development, and really helping them kind of find where they fit in this world of additive manufacturing.
Excellent. Thank you, Luc, and great to have you with us. On May 6th, 2022, President Biden joined 5 leading US manufacturers to celebrate the launch of Additive Manufacturing Forward, or AM Forward. AM Forward is a voluntary compact among large manufacturers to help their smaller US-based suppliers increase their use of additive manufacturing or 3D printing. Why do you think this is important? Why is AM constantly being hailed as the transformative technology? If additive is so great, why are we not yet printing everything? What do you think?
Yeah, excellent question, right? So when President Biden introduced this effort, it was really a boom for all of us in the additive manufacturing industry. And the primary reason for that is that the focus is really to address the supply chain bottlenecks that are there. So for example, right, it's very important to set up and to qualify an entire AM supply chain. It's easier to say that sentence than it is to actually set up, but to be able to set up that supply chain will lead to further additive adoption. And with that further additive adoption, you get, further usage, you get further educational pipelines, and that also spurs a lot of R&D activities as well. It also helps the small to medium government suppliers to adopt AM. So again, right, aiding in the adoption of additive manufacturing across the entire supply chain, getting more people to use additive manufacturing and to realize and take advantage of the benefits of additive manufacturing. And with all of that, it will help to address the lead times and costs. So this is especially in the realm of low volume and high mix sectors.
Well, okay, I understand the impact on supply chain, but the question I have is why additive? Why do we need to develop a new manufacturing technology? Why can't we use the manufacturing methods that we already have and know and been using for a very long time, for centuries, like casting, for example?
I don't think that anyone is advocating for additive manufacturing to replace any of the other manufacturing methods, right? Ultimately, additive manufacturing is another tool in the toolbox, and it enables technology. It enables the supply chain in these areas where it's very difficult to get products. From a technology perspective, if you start thinking from an additive manufacturing perspective and you are using design for additive manufacturing principles from the get-go, then you are able to customize your part for the application. What I mean to say is, for example, if you need the infamous case example for additive manufacturing, is that if you have a part and you need a hole through the part, you don't start with the part and you put a hole through it. You start with the hole and you design around that hole.
So this is a different design imperative and different approach. But then what is the impact on lead time and supply chain, as you mentioned earlier? Why is it so much faster and easier to use?
Yes, there's a couple of different areas where additive manufacturing can help, right? One is through the development phase. So rapid prototyping, for example, that always moves quickly. And then through the supply chain perspective in and of itself, when you are trying to print or manufacture a part, you can print and manufacture that part closer to the end use. So the logistics of moving a part from one vendor to another vendor, to this vendor, to that vendor is much simplified. You're starting with a common feedstock for all the parts that need to feed that supply chain, and then they can be processed together and then delivered on demand.
So with AM forward, I think one of the benefits that I understand is they're trying to make America competitive on a global scale with manufacturing. Is this something that you will agree with for the goal of AM forward?
Yes, I agree with it from a manufacturing perspective. I think one often overlooked item on that point, though, is that feedstocks are required. And so, being a materials person and coming with a bit of an education even from the mining point of view, is that these feedstocks are not positioned or geographically located in areas where they'll necessarily be used. So to a certain extent, we still need to work globally to be able to identify and find and mine those materials and then be able to transport them to that point of use. So yes, from a manufacturing perspective, I completely agree with that. From a raw materials perspective, oftentimes some of these materials of high value are not necessarily located in a geographically convenient area.
Yes, I think I understand. I had the pleasure to work within logistics departments at my previous employers, and usually we look at the composition or the bill of materials for complex assembly, and different parts sometimes come from different vendors, so they go through multiple vendors, and one vendor does one operation, another vendor does another operation, and it's a very complex supply chain that you go through all these steps to get the final assembly. Now, if you say with additive, I can eliminate all these different steps and print that final assembly at the point of consumption, this provides a lot of benefits and literally eliminates logistics and all these complications and bottlenecks. Is this where you think the application is, where the benefits are?
I think for applications where there is the high mix, low volume, I think absolutely, right? I think it definitely simplifies supply chains there. There's another point of use for additive manufacturing that I don't want to neglect, and that's areas of customization. So where you need parts that are specifically customized for the application itself, that's another benefit as well, to be able to accelerate through this design and qualification life cycle, to be able to manufacture the parts specific to application. And in particular, right, as I think a perfect example would be for the medical application. So for medical implants or prostheses, being able to manufacture not an implant in, let's say, 3 generic different sizes, but being able to manufacture parts that are specific to that patient.
And do so right in the operating room.
I think eventually we could see that, understanding that this is a podcast that's looking kind of into the future. I think that there's certainly opportunity for that.
Let me jump in for just a moment here. When you talked about designing around the hole instead of designing a part and then drilling a hole, that knocks on the door of a bigger concept, I think, and that is that by the very method of manufacturing, additive allows you to create designs that are simply not possible using the older casting and then machining techniques that have been used for a long time. Could you talk about that for just a moment?
Yes. So from a casting perspective, there's certainly a lot of opportunity there. The casting method of manufacturing in and of itself is not long, it's not expensive. The cost and the lead time is to create the moldings and the tooling for the, for said castings and for said machining. So being able to eliminate that part of the casting operation to create the part is invaluable.
So is additive just then a novel manufacturing method, or is it something bigger than that? So going back to your material science background and metallurgy, is there a deeper connection between material transformation and additive process? Do we need to relearn everything we know about metallurgy as we develop these new processes and materials for additive? Is this a new research science area?
It is a new research and science area. I would say that from my perspective, additive is as much a mindset as it is a novel manufacturing technique, right? From a technical perspective, it's welding. Welding has been around for long time, but at a scale that was never envisioned and still hasn't been. Even when we're looking at additive manufacturing using a wire arc deposition, which is traditional welding, we're using that method, which is, again, has been around for a while, but using it to build up and to manufacture as opposed to simply joining materials. I don't think we need to relearn everything that we know about metallurgy, but I think we do need to learn more. Right? Not to get just too technical about it, but we can start exploring different areas of phase diagrams and TTT curves to really start improving stability of what were once only kind of semi-equilibrium phases. And with that regard too, right, we've seen that for many additive manufacturing materials, there are novel heat treatments that we can apply to actually improve material properties beyond what we saw with conventional materials, whether it be wrought or castings.
All right. Thank you, Luke. Appreciate that.
Look, I really, from what you said about the benefits of AM, especially with dealing with customization and supply chain bottlenecks, from what I understand, AM technology is really changing the way manufacturers think about the entire life cycle of a product, from design, production, and distribution all the way to the end of a product's life. So AM in itself offers this flexibility in product design and production. And for small businesses, especially entrepreneurs, they want rapid design and a quick speed to market. And mostly now they're using traditional supply chain methods. So additive manufacturing is also being mentioned as a critical component of a digital supply chain transformation. So what does this mean exactly, and why is it important? I mean, we still need physical goods. So are we talking about eventually moving products from the physical world into a digital virtual space, such as a metaverse in some sense, or is it something totally different?
So awesome question, right? I always love the scenario that instead of companies keeping physical inventories, we're able to keep quote unquote digital inventory. And that when they need to pluck from the inventory, instead of reaching for a physical good that may be kept in a warehouse X number of miles away, they're able to use a manufacturer that's a little bit closer to the point of use. To be honest, I find it to be a pretty futuristic perspective from a practical standpoint for current heavy adopters of additive, as well as requirements for post-processing. Because even in additive, there's an economy of scale factor at play.
I really wanted to dig deeper into telling the listeners, I guess you can start with a definition of what is the digital supply chain and how does AM play into that, especially when it comes to, say, printing parts on demand. And like with COVID-19, there was a good example that they needed personal protective wear. So if you can just kind of have the listeners understand how or what digital supply chain is and how AM plays into that.
Yeah. So when I think of digital supply chain, I think about this aspect of kind of creating a digital twin of the part itself, and that digital twin of the part is not only the part model, but also all of the processing, all of the characteristics of the part, the end application needs for it, the heat treatments, etc. All of that is kind of tied together into one digital twin, if you will. And again, I kind of come at this from the metals side, but when I think about this, I think about accelerating really the qualification of the part. When talking about PPE and some of the other parts, especially with polymers from the consumer perspective, I think that there is a little bit more leniency, especially with PPE during COVID. Time to market was really the primary driver. For other applications where quality is really the driver, the qualification perspective of that digital twin and how that aids it and really gives a specific set of instructions to the manufacturer, I think that's really where it plays a key role.
Can you explain a little bit more what does it mean by digital twin?
Mm-hmm. Yeah, so when I consider a digital twin, it's the part, the characteristics, the geometries, the tolerances, the mechanical properties, the chemical composition, even the application characteristics, right? All of that is tied into a specific model or a specific digital package. And that digital package is then the twin of the part. So when a manufacturer is looking for that particular part, again, instead of reaching for a traveler or an SOW and they pluck a bar off the rack and start the manufacturing process, they're able to take the model and the part, all of it together, right? This kind of set of instructions of how to process and send that to the manufacturer. And then in return, they get their finished part with the properties through the qualification process, and it's ready for use.
So let me jump in for a moment, because digital twinning goes even further, doesn't it? Where you create the part and perhaps it's all qualified for a particular application, but then you want to test it. You can begin your testing in silica, so to speak, as opposed to in a physical form. So that kind of plays a part in digital supply chain too, doesn't it? So you've created the part, you have the digital twin, you say, oh, I want to use it in a slightly different form or application. Let's test it in the computer first. Then we can crank it out from the additive manufacturing device and do physical testing, but it collapses the time to use from the traditional techniques. Can you talk about that for just a moment?
Yeah, absolutely. So I think that there's certainly opportunity to compress some of that. I think where we as a society really kind of need to move forward on, or where there's opportunity to move forward on, is the qualification step. So where a lot of this qualification testing and such could be done in silica, as you say, which I love. I've never heard that before, but I really like it. There are relics of history that require testing from an application perspective. And again, going back to President Biden's AM Forward initiative, right, being able to encourage some of the suppliers to share some of that application data to kind of grow this database to be able to share amongst suppliers, I think that's going to be incredible for the AM industry as a whole.
So let's speak into the future a little bit. I'm constantly reading about new methods, new discoveries in additive. For example, just read recently that the first multi-story building house is being printed in Houston. Then Relativity Space is talking about printing rockets going from design to launch in 30 days. Robots made of piezoelectric metamaterials and so on and so forth. What else is on the horizon? What makes you excited? Can you imagine the future here? Where can it all go?
Yeah, absolutely. So from my perspective, and maybe this makes me a little bit more on the boring side for a technology podcast, but what excites me is to see this continued uptick of adoption for additive manufacturing, right? The continued industrialization. So people using it in more use cases, heavier usage of additive manufacturing. And I think that continued adoption in itself will drive innovation. Also, the medical realm, so being able to customize additively manufactured parts for the patients, I think that's super exciting. I think that being able to enable hypersonics, right, that's a booming field right now. That's mostly being driven by military applications right now, but I think if we can move that to the civilian space, I think that'll be super exciting. But that's kind of where I'm looking at from my perspective right now in additive manufacturing.
Tell me about hypersonics and why additive manufacturing is important to that, because that sounds really interesting.
Yeah, so it all comes back to these kind of unique geometries. With any sort of engines, there's very intricate flow paths for fuel, for coolants, for air, etc. So it basically enables the continued evolution of this buy to flight ratio, which is a very common terminology in aerospace. It's effectively, how much material do you have to buy, and then how much material actually flies? And you want that to really be as low as possible. But again, from the hypersonics perspective, it's about enabling new geometries, about enabling the manufacturing of it, and also enabling these new materials that may be incredibly difficult to get in the bar form, but being able to use them for the hypersonics applications.
Okay, so that's a real concrete and really sexy thing to look at, an example of something you could make with additive manufacturing that's simply not possible using traditional methods.
Correct. Hypersonics, rocketry, there's a lot of work that's going on right now. Medical devices as well. There's a lot of use applications. I spoke very heavily from supply chain perspective from the get-go, but from an enabling perspective, aerospace, space travel, medicine, these are all fields where additive manufacturing enable new uses and new applications.
Being a material scientist, can you talk about multi-material applications? Because with the help of additive, you can basically distribute any material anywhere within that space, within the shape, make them work together. Where does this trend go?
There's some early work going on right now about printing multi-material parts and creating, for example, material gradients in specific parts. I think that that's a super, super interesting field. I think that, again, right, one of the holdups for widespread adoption is in the qualification phase of it. And then if we look back to kind of creating the digital twin, creating a digital twin of a material gradient that is aligned with the physical manufacturing of the part, I think is a very big challenge that's out there. And I'm looking forward to seeing where that space grows.
Yeah, that's the question I had for a long time. How do you qualify a part made of multi-materials or with gradient of material that's with properties different from one area of the part to another area of the part? That's not like using the material that's pre-qualified and you make the shape out of it. You basically distribute in different materials across the shape. How do you qualify that?
Exactly. Even if you take a look at just something that you would think would be a simple geometry of laminated materials, well, if you start zooming in at the interface between those two materials, there's a gradient that's there. There's not hard boundaries between the two. So that's, effectively introducing tertiary, maybe even, fourth or fifth phases to the material equation.
If you don't have those gradients, then you don't have a proper joining, right? And you would have delamination in the example of laminated material, right?
Oh, exactly. Yeah. The gradients will always be there. The question is, how do you qualify the piece of a whole? How do you characterize those gradients when the gradients themselves are a gradient?
Yeah.
Yeah.
So no, I wanted to just follow up on what you said about adopting AM, especially for medical devices, because I work with a lot of startups, and one of the problems that they encounter is if they want to develop a device where it's flexible, for example, to use in surgery. So since, this is not my field, I was wondering, why is it so difficult to have materials that can be 3D printed, that are flexible, that can be used in surgical applications? Do you think in the future, near future, we'll have something to work with?
When I look at what's going on right now with the adoption of additive manufacturing, the biggest adopter and use case right now is in rocketry, of shooting satellites or whatever else up into space. And I think that that's fine, right? And I think that there's a reason for that. And it's, if you use it and if something fails and a rocket blows up, you lose a satellite, you lose money, but no one's life is on the line. But when you talk about something from a medical perspective, or if you talk about something from even an aerospace perspective, the regular John Smith who may be putting himself on an airplane, he's signing up to go from one city to the next. He's not signing to put his life on the line. So I think that there is still a risk there. I think that, we live in a society that's, the court systems have definitely woven themselves into. And I think that from what we used to call in the oil field, the CYA perspective, I think that there is a lot of testing and, quite frankly, necessary and good testing requirements that are required prior to inputting some of these or implanting some of these materials or parts into the human bodies of patients.
And one of the things that some of these companies mention is just, cost. They obviously want to do 3D printing to test their devices. And in many cases, the raw materials are not available. So then they have to turn to injection molding. So sometimes as a early stage company, they want to adopt AM, but they just can't just because of the lack of certain materials that they need. This was just a problem that I encountered last week. So I just wanted to hear more about it.
Yeah, to be honest with you, I don't really play much of the polymers arena, so I can't really speak too much to it. I can guess on it, but I'm afraid I don't have too many smart things to say about it.
That's all right. Thank you.
The polymer space is rapidly growing as well, and I think from the industrial perspective, there are lots of applications now in the medical as well, and in the industrial for mass production. And just think about Invisalign application, dental braces being printed all over everywhere.
Absolutely right. I think that polymers is growing like wildfire. Metal is certainly seeing an uptick, and I think from what I hear from a couple of different avenues is that ceramic additive manufacturing is quickly going to be a very new hot field in the short time frame.
So, and then thinking about the future, what trends do you see happening with the help of additive or even beyond additive? Where will this lead humans in, say, 50 years, in 100 years, or even in 200 years by the year 2022? Will we even survive that long? Will we settle the solar system? Will we reach the stars? Will we be able to print anything we want anywhere, anytime? What are your thoughts?
Yeah, I'm an advocate of the human spirit, right? I think that 200 years down the road, if we look back 200 years ago, is actually kind of a blink of the eye. So I think there's been a lot of advances. I think, will we be printing everything everywhere? I don't necessarily think so, right? Ultimately, additive manufacturing is another tool in the toolbox. And, for better or for worse, economics do have a play in this. If we look much, much further down the road, what is sort of exciting to kind of free the mind and think about could be self-assembling materials, or let's say nano robots that self-assemble into the parts themselves. And that's super exciting. That's super fun to think about. I think if we zoom in even further, though, I think we start getting into self-assembly of, let's say, zoom in at the atomic level. I think we start thinking about self-assembly of atoms and, let's say, even protons and neutrons. Well, then we start playing with the field of alchemy. And alchemy's been around thousands of years. And we haven't figured out in 1,000 years. I don't know if we'll figure it out in the next 1,000.
And this is really interesting, that point you bring in, this nanofabrication, because the common stuff of the universe is the same. You're thinking about protons and neutrons and electrons, it's the same. So can you rearrange it and create any material, any structure, anything you want using those nanofabrication approaches, self-assembling robots? But as you're saying, yes, it is an alchemy. But can we now, with all our knowledge and learnings that we've created throughout the ages, now with quantum mechanics, with the deep understanding of these different fields of physics and materials, can we push that boundary? Can we actually do alchemy?
I mean, super interesting to think about, right? Especially from a materials perspective. I think zooming in even further, right, from a quantum perspective, can we somehow improve even the computational capabilities of materials? So moving past what we think is physically possible today, but being able to move around subatomic particles to create effectively our own universes. And we can create universal simulations that are obviously totally not possible today. And then here comes the question, right? If we can think about it, has it not already happened? Are we living in a simulation? It's a fun question to think about.
Yeah, now we're in the realm of metaphysics and philosophy.
Exactly.
Yeah.
Exactly.
Yeah, thank you.
It's like internet. Was it the rule 72 of the internet? Is it 72? If you can think of it exists, then it does on the internet.
Well, there's a lot of dangerous paths on that.
Correct. Yes.
And it's almost along the line of if you can create your own reality, right? Go into manifestation side of things. So all what you mentioned with the nanorobot, self-assembly, alchemy, it's amazing to think about what we can imagine for our future. So thank you so much for taking that imaginary trip with us and our listeners. So do you think that actual time travel is possible? And if yes, is it only forward, only backward, or both ways? And what about the paradoxes of traveling into the past?
Yeah, I think this is always like a very fun thought experiment. And to be honest with you, I was talking with a friend the other day. Both he and I are huge suckers for these alternative timeline sci-fi series that are kind of popping up right now. I'm not really a believer in backwards time travel, but I am a big believer in the law of unintended consequences. So even if we were able to travel backwards in time, I don't think that we could do so with any sort of intention of fixing, quote unquote, something, right? Whether that be any number of atrocities that have been committed throughout the years. I think that trying to change one item to, again, kind of fix something would just open the doors for some other instance or some other activity or some other, a war, for example, right, to take place. It just opens up opportunities for some of these bad actors to step in. It's just the nature of where we are.
So if you had the chance, based on what you said, that it might be difficult, obviously, to go to the past, but this is just a question that we ask all our guests. If you had the chance for just one trip, if suddenly a time machine just showed up in your living room and it said, you can go either backward or forward in time, where will you go, and explain your choice and your reasoning behind that?
Yeah, so the joke that I always tell is that in grad school, I had a colleague who offered to help me buy Bitcoin back when it was under a dime. And I thought, I've got $100 I can spend somewhere else, so I'm okay. So that's always a bit of a regret, but who knows what would have happened if I would have taken that offer. I would have had the crypto key. What if I lost it, misplaced it? Well, I think losing tens of millions of dollars is probably worse than never having it to begin with. So that's kind of the jokey answer. I would say, from an honest answer, if I could go back in time, one time in my life, I probably would like to reserve it until I'm quite a bit older, maybe on kind of death's door, and then just use it to go back in time and just kind of relive life. I think that the human experience is unbelievable, right? Whether it's making friends, falling in love, figuring it out, falling out of love, having kids. I mean, everything is just so absolutely unbelievable that we go through. And just to be able to do it all again, I don't know if it's possible. I don't know what's waiting on the other side. I kind of approach it as we have one buffet line, so stack it up as you walk through. And if I get to do it again, then I'd stack the plate twice as high.
Right. And what about even outside of your own lifetime? I mean, would you go back, 100 years, 200 years, or even go forward into the future, 500 years? Where would you go?
So I don't think I would go back in time as a futurist. I think I'd probably go forward. I'd go forward in time. Yeah. But again, it's a double-edged sword because you lose everyone that you lose your loved ones, you lose your kids. And so I think it would be a very double-edged sword. But if it was out of a curiosity perspective, yeah, I would love to travel. I'd probably say about 1,000 years into the future. I think we're assured to still be around for about 1,000 years. I think 10,000 is probably a bit of a stretch. I'd hate to go into the future 1,000 years and be the only human that's around, surrounded by ferns and then whatever the next generation of dinosaurs look like.
Right.
But I think 1,000 years would be pretty fun.
AI, surrounded by AI.
Exactly.
Okay, thank you so much, Luke.
This has been an awfully fun talk. My job is to summarize at the end of the call, but there's so much that we've covered. I'm not sure what I would say, but I really appreciate your explaining the digital supply chain, explaining additive manufacturing and some of the possibilities there, because I think a lot of our audience will be interested in that. And also the kind of care that you take in your explanations. You're at the same time a futurist, but a realist. And that's really refreshing because obviously we want our people like you who are at the leading edge of technology to be using it wisely. So that's kind of in a sense, it's kind of a relief. But tell me something, if you would, if you had just a couple of sentences to describe where we are in your field in additive manufacturing and where you think it will help us go in a broad perspective, what would you say?
So I think with additive manufacturing, I think that we're over the big hump in the hype curve. I think that maybe we're even almost over the trough of reality hitting, right? Where now we're actually into the adoption phase. And that's what I think is super cool, right? I mean, additive manufacturing, very cool technology. Using additive manufacturing, even cooler. So that's where I would like to kind of leave it. I think that we're still in the early phases of adoption, and it's wild, right? Additive manufacturing is still a very, very young field, but we went through the hype curve very fast, very rapidly. And I think for the most part, we're into the adoption phases. And I'm very, very excited to see where that's going to take us into the future.
Neat. So where, if people wanted to look at some more information, kind of go on their own journey to learn more about this, where would you suggest they go, whether it's online or to some kind of journal or another sort of source of information?
Yes, so there's a ton of information that's online. There was recently an open source textbook that was published on additive manufacturing, maybe a little bit dry for some of the audience. Also, everyone is able to reach out and to contact me, connect with me, and depending on specifically what they're interested in with additive manufacturing, I'm always very happy to either make connections or to point people in a certain direction.
So that means we can give people some of your contact information, and you'll be open to that.
Yeah, LinkedIn is probably the best route.
And there's not a lot of Luke Boyers, so I think that's pretty easy. So Luke Boyer at Carpenter.
Yes, Luke Boyer at Carpenter Technology, Luke Boyer at Carpenter Additive.
Right.
My profile picture on LinkedIn is me sitting with my kid working away on the computers. She's a futurist.
Well, children are the best futurists.
The imagination that the kids have, the kids aren't constrained, right? When they consider what is real or what could be real, it's a much blurrier image for them. And so it's inspiring to be around them, to watch how they think, how they problem solve. Yeah, I would agree with you. The absolute futurist.
Super. Anybody else have anything else to say?
No, I just want to say thank you. Great conversation. Really appreciate your time and insights. It was fun.
Thank you, Luke. It was great having you here.
Thank you for listening to this episode of Vision 2222. And if you enjoyed what you heard, please subscribe, like, and share with your friends. Please also comment, and we'll do our best to respond.